So thanks a lot to everybody. Thanks a lot to DotNext conference, to this REST conference. This is my first time here in St. Petersburg, also my first time in Russia. I'm very delighted for the kindness of everybody, and I'm really happy to be here. Thanks to the sponsors. Also thanks to you for coming. I was so happy to be here that last night at the party, I was asking my Russian friend, how could I say I'm very happy to be here in Russian? So, but the Russian is a very difficult language for me. So I was asking him the whole night during the party while the other people were drinking beers. I was asking him again and again, but finally I think I got it. It was Nie sprasivice volsha minya. Did I say it right? Okay, so let's start. So let's start with the boring part, which is my introduction, sorry. But let's go through this quickly. Who am I? That's my name. You saw it before. It was Alfonso García Caro. I'm from and also living now in Madrid. I have a degree in linguistics, so I kind of self-taught programmer. I suppose that many of you are in the same situation. And most of my experience is in desktop and web application. And this is what I'm going to talk about my journey from a desktop application, an imperative approach to UI programming, and to web applications and a functional approach to UI. I have experience in multiple sectors like video games, education, green energy, commerce, and genetics. Unfortunately, I don't know about all these things, but I was creating apps for them. And I also know, because I have the creator of Fable, I don't know if you have heard about it, it's an F# to JavaScript compiler. It's an open source project, okay? We'll be talking about that next, and we have some stickers here. Feel free after the talk to take one of them. And I'm also co-author of Master in F#, which is a book published by Pact Publishing. So if you're interested in the language, you can also check it out. And I'm kind of a freelancer or mercenary or running samurai without lord, whatever you want to call them. But this is the company I'm collaborating with right now. This is the metrics, and we are working in the genetics to create some, to harvest some of nature's gifts, as it's called here. This company has been mentioned in many articles in some of the most, the best magazines in science and nature and economy, so it's worth checking out, themetricsbio.com. So let's go through, talk about the UIs. So first, we are going to define what's a UI, okay? First, we are going to go through a low level. So in low level, what do you do when you want to create a UI? What does a UI do? First, it retrieves data from a source, at least most of the time. It renders pixels on a screen, because at the end, they are just pixels, okay? So we have to render some pixels. We say this pixel will be black, this pixel will be white. And then we have to interpret signals from the computer peripherals. It can be a mouse, it can be a keyboard, it can be a touch screen, but they are just electric signals, okay? And then we interpret them and update the data. And finally, we go back to 2. We render pixels on the screen, we interpret the signals, and we update the data again. But this is not what we actually do, or what we actually think about, okay? We usually think in a higher level. In a higher level, we retrieve data from a source, same. But now we talk about controls, okay? Usually in all UI frameworks, we talk about familiar controls, like a button, a text input, a checkbox, etc. This is very good because we don't have to think on the pixel level, and also because the controls are familiar both to the developer and the user. So this is very good because it's much easier to use a UI if you already know more or less how to click a button, to touch a button, to check a checkbox, etc., etc. Also, very important for the developers that these controls have events. So we don't have to worry about the electric signal that is produced when the user hits a key in the keyboard. We just get an event, and the event will tell us a key has been pressed, the key was P, B, whatever, and then we can react to that. Much easier. Then we update the data and go to 2. So this is the same. It's the same. The only thing that changes is that we talk about controls and we talk about events. Okay, so let's see some of these frameworks. How many of you have used Windows Forms? Can you raise the hand? Okay, yeah, most of you. How many of you still use Windows Forms? Well, a few people. Yeah, they're still in use. And I guess that when you use them, the Windows Forms, you love them. And for many .NET developers, it was the reason to start .NET development, because you could use Visual Studio, you could prototype a form very quickly, and then have an application running in very, very short time. So, what was Windows Forms doing? Or in general, this imperative approach to UI development. So first, we model the controls, these controls, the button, the checkbox, the text input, we model them as objects. So this is very good if we were using the object-oriented programming model. And the UI is built by instantiating, by constructing these objects, and then we modify the properties. The designer, a graphic designer, can help very significantly. We have in Visual Studio that we can just drag controls to our form, and then this can be very quick for prototyping. Most of the logic for these kind of programs go in the event hooks. So when we want to do something, we take the event of the control, and then we put the logic there. And the hooks, these hooks, can modify both the data and also the UI control. So let's see an example. Sorry, it's a bit small, but it's a very quick example. Imagine that we have a form, and we have a button and a checkbox, and we want to disable the button if we check the checkbox. So what do? We go to the designer, we just click, we just select the click event in the checkbox, and then we go there, and we have a reference to the button, and we set the enable property to true or false, depending on whether it has been checked or not. Okay? Quite easy. What are the advantages of this programming model? First, as we said, it's very quickly to prototype thanks to the designer. And also, because we are talking about the object-oriented programming model, we have the hierarchy of controls and layouts, which fits very well with this model. Also, we have talked about having this logic in the event hooks, keeping references to the UI controls, modifying the state. This can be quite complicated if our application grows large. So what do? We have a pattern, very easy. It's a model view controller. So it just means that if the logic becomes quite difficult to control, just move the logic out of the view code and the model code, and you have it separately in a thing that we call the controller, so we can control the controller. Much easier. Separation of controllers, one of the principles of programming. But it has also some problems. First, the code generated by the designer cannot be touched, or at least it's very difficult to touch. I don't know if you do, but I usually didn't dare to touch the code generated by the graphic designer. This means that the UI is not very dynamic. So this was one of the reasons that Windows Forms were phased out, because users were expecting the UIs to be really, really dynamic, to be responsive, to change things very quickly. And the Windows Forms makes it more difficult, because you design things, but it's more difficult to change them dramatically. It's also difficult to create custom components. There were some companies that were selling custom components for the Windows Forms, but it's not, for the individual developer, it was not common to do it. In the web, what was happening in the web? Because I'm going to go to the web at the end of the talk, so I'm going to make a comparison. So what's happening in the web application development, in the desktop and also in the web. In the web, we have something very similar. We watch the DOM, okay? The Document Object Model. It was something very similar. It was just modeling the controls, the button, the checkbox, etc., as object-oriented programming objects, okay? It was quite difficult to manage this API. It was not a very API that was very easy to use. So then jQuery came. jQuery made it more tractable. And I don't know if you have used jQuery or do any web programming. Have you used jQuery? Okay, some of you. So you know it quickly became the standard, because it was the difference between using jQuery or not using jQuery. Even some people prefer to use what they call vanilla JavaScript. Still, jQuery, it was such a, it gives you a performance, not a performance, but a better development experience so everybody chose jQuery, okay? But it still was imperative, so still you have to take the reference of the element, you have to modify the properties, and hope that everything will go fine. Also, in the web, you have very basic native controls and no styling, so you have to use CSS for that. And there are some designers available. They are not very popular nowadays, but before we had, for example, Dreamweaver, and people use that to something similar to what Windows desktop developers were doing with Visual Studio. So let's move to the next step in Windows desktop development. Was any of you know what Wpf stands for? Yeah, Windows Presentation Foundation, okay, yeah, great acronym. Everybody loves that. How many of you use that, or have you used it? Okay, yeah, quite a few. So I think you like it. Yeah, it's good. I like it when I was using it. I think there were many improvements of the Windows forms. When we had WPF with MVVM and SAML, there were many improvements. The biggest one was that you cannot fit more acronyms in a shorter space. This was a big hit even for Microsoft, okay? What are these acronyms for? SAML, I don't even know what that means, but it's a declarative language similar to XML. I guess that's why it's called SAML. And it's a declarative language for the UI because the purpose was to separate the code for the UI from the code for your logic. Okay, and we have, for the logic, we have the MVVM, the model view model pattern. This pattern just means that you're going to link the UI and the model through magic bindings. Okay, you know, most of you, I guess, know what bindings are about. So you just take a property in your model, and then you say something in your UI, for example, the color or the state of a checkbox, and you say, this is going to be linked to this property of the model. And the framework will take care of updating each of them when there is a change. But there is a lot of logic still happening in the events. This hasn't changed, okay? We have the bindings, but we still have to write many things on our own. What are the advantages of this approach? The first advantage is that we can use, I think this, I love this, that you can use the software designer and also edit the UI code, because this was much more difficult with Windows Forms. But with XAML, you can have the designer, you can use the designer, but whenever you need it, you can just edit the code directly. This is good. And also, designer, this time I'm talking about a person, the designer and the programmer can work separately. So somebody can specialize in the UI, they can write XAML code, and then the programmer can just hook the events and create the logic, okay? It's easier to write components. It's easier to write things that are reusable with XAML. And it's easier to have custom styling. With Windows Forms, usually all the applications look the same, but with XAML, you can have some applications with a more personalized style. You can see here in this screenshot what XAMLs look like. It's very similar to XML. And then you have the designer on the right. And then you can see that we have some bindings in the tags in the XAML language, okay? So for example, in the entry password, we are going to bind this to the password property of our model. Very easy. In the web, what was happening in the web? This idea, I don't know what came first. I don't know well about the history of software. But it's true that there was these data bindings libraries were got very popular in the web, and there was like the song yesterday about the frameworks. Everybody wanted to write their own frameworks, so there was like Explosion, you have Backbone, you have Knockout, you have Ember. So there was a moment that there were many possibilities to create something similar to what you could do with WPF. And there's also the introduction of the template system. So similar to XAML in a sense that they made the HTML dynamic. HTML is not a dynamic language. It was thought to be just to describe static documents. But thanks to these template systems, like handlebars, for example, HTML became dynamic, and you could use data binding to bind the properties in the HTML with properties in your model. So most of these libraries, they phase out. I think very few people if anyone is still using some of these libraries, but the Vue.js is still the survivor, and it's still very popular. So this has the template system, and this has also the data bindings. So it's kind of these ideas from Wpf applied to the web. Problems with this approach. The first problem is that we need to learn another language, okay? SAML is simple, but still you need to learn something new. If you are with SAML, you learn SAML. If you go to the web and want to use Vue.js, you have to learn their template system, the way to do the binding, etc. It's still different, okay? Bindings can also get complex. The bindings idea is very simple. So, you bind something in your UI with something in your model. It's very simple, but then you have one-way data bindings, two-way data bindings. You have triggers, okay? So it can get complex very quickly. And SAML, the language, is still limited because it's a declarative language, and some operations require tricks from the framework. So for example, if you want to have, we saw before how to disable a button. If you want to disable a submit button, this is something very, very useful in a form. You're having a form, but you are making validation on the fly, and you don't want to enable the submit button until the user has filled everything correctly. So this user in Stack Overflow is asking how this is possible, and the answer is to use the command model, command pattern. Command pattern is also a new kind of binding, so there's also a new thing that you need to learn. You see here, how do you apply that to a button component? And then you see here at the bottom, this is the simplest way to do this is like this, okay? So you still have, for something that you could think that is quite simple, you still have a lot of code. Not all the code, for example, here the grid is for this purpose, but you can see that we have to make this command binding in the SAML side. You have to put the namespaces on the top properly. Then in the code behind, because we still have some code behind, some code in C#, you have to use this on-property change event. You have to use the notify handle. So you still need to learn new things to do some specific things, okay? So every time that there is a basic idea, but every time that you want to do something, you need to learn something new. Meanwhile, in the web, what was happening in the web? Okay, because in the web, some people criticize that, and it's true. The web is a crazy world. It's people do many different things, and it seems it's very difficult to set up a very simple web application. But on the other hand, it's true that this makes it easier to try new ideas, because in the desktop, it's so difficult to create a framework that we trust. For example, in .NET, we only trust in Microsoft to do something like that. It's very difficult that somebody else, some other company is going to create a full UI framework. Usually they put something on top of that, but it's not possible that somebody is going to create something new. But in the web, we have these new ideas. And in recent years, we had these two. Do you know these logos? Well, this left one is React, and the right one? Elm. Okay, cool. You know about them. Okay, so they have these two things. They are not, they are independent, but they are somehow related. I don't know who was first or not, but React came with, it's a render engine, and Elm is a language, but I'm going to focus here on the programming model, on what we call the Elm architecture. Okay. And these are related to functional programming. I don't know, there was a talk before about functional programming. I don't know if you listened to that. But the functional programmers, if you know some of them, if you have been talking to the community, they have drunk the Kool-Aid on functional programming, and everybody thinks that the functional programming is the solution of everything. I don't know if that's true or not, but let's see if functional programming can help us with the UI. Okay, so first we are going to talk about React. React, the most important thing, the most important innovation from React was the virtual DOM. Okay, the virtual DOM is something that stands before, because we see that manipulating the DOM is difficult and also affects the performance of your application. You can have something in between that is easier to handle, and the framework, in this case the React, the library, will take care of doing the actual manipulations to the actual DOM, based on the things that you did with the virtual DOM, okay? This allows us to write UIs declaratively Sorry, this a word in English that I don't pronounce very well. But you can write declarative UIs using the same programming language. You don't need a different programming language for that. And also, another very important idea from React is that everything is a component. We've been talking about the UIs for a very long time, that everything should be a component is the best way to reuse. But there were different ideas about what is exactly a component or how to write a component. In React, they have their own way. But the important thing is that everything is a component. So it's the unit you think about to build your UI. And one of the good things about React is that components can be functions, okay? And functions are really easy to compose, okay? So when you want to reuse a piece of code in your application, what do? You refactor it. And what's usually, I think there is an option in Visual Studio to that. When you refactor, you just take the code and put it in another function, because a function is the easier way to just call it from somewhere else. Okay, and also, very important and related to functional programming is that React encourages immutability and also one-way data flow. We were talking about two-way data abundance, etc. But in React, we usually have we only have one-way data flow, okay? The information can only go through the parent components to the children. I said that we are using just the same programming language. So in this case, in the web, it will be JavaScript. But if you know some, have you written or do you know something about React? Can you, okay, yeah, okay, good. So probably you know that React, when you see a React application, it looks like the thing we see on top of the slide, right? And you say, this is not JavaScript, this is HTML. Okay, yeah, this is because the people who created React also thought that JavaScript was not, still was not a good language to express things declaratively. So they created this plugin to have some, it's actually only a syntax sugar, because what you see on top will be converted, what you see on the bottom, before sending it to the browser. So what you see on the bottom is what is actually running on the browser. So basically, we are defining UI, but it's just calling functions. In this case, just create element that is a function that is coming from the React library. Okay, let's go to the Elm architecture. The Elm architecture is being popularized by Elm. Again, I don't know exactly if there were those who invited that or it was coming from somewhere else, but also there is an alternative name that is Model View Update. So it's similar to what we saw before, this model view controller, but this time it's a bit different. Let's go through each of the parts of this statement. Model this time, the important thing is that the model is an immutable data structure that defines the UI at a specific point, okay? So the model is like a snapshot of the UI. So this is very important because in the other approaches we saw, the model is always mutable. Mutable, yeah, it's, you have to modify properties of the model to update the data. But in this case, we have immutable data structure. Every time that we want to create the model, we want to update the model, we have to create a new one. The view is also a pure function. Pure function is very important in functional programming. It's functions that don't have any side effects. So the function is not going to modify the DOM. The function is just going to define the elements, and as we said, is the framework which is going to be responsible to modify the actual elements on the screen. But this is transparent for us. For us, we just think of the view function as something that is creating a new UI every time, okay? So it's taking the model and then transform it to UI elements. And the update function, this time, is a function that it takes the current state of the model, it takes a message, and then returns a new copy of the model. Okay? Does it sound familiar? Sorry? Reduce it, yeah, we'll see Redux later. Redux is a variant of the Elm architecture, okay? It's, we are not going to talk much about the Redux, but it's true that Redux is the one that is more popular in C#, for example, or JavaScript. I'm going to focus more on the Elm architecture. But yeah, I was thinking of something else, something not specifically related to the UI. Have you heard about event sourcing? CQRS, there was another acronym, the .NET needs acronyms, I don't know why, so you heard about that. So in event sourcing, you also have an update function that is taking a message, or events as they call them, and then returns a new model. And the advantage of this is that if you have the streams of events, usually these events are stored in a database, you can just rebuild your model at any point, okay? So it's happening exactly the same with the UIs using the Elm architecture. We didn't have many diagrams in the talk so far, sorry. So let's see one. So let's see the diagram for the Elm architecture. We have just these three themes: model, update, and view. And you see how each of them is related. So the model goes to the view. The view receives the model, converts it to a new UI, and then sends message to the update function. And the update function creates a new model, and then we start a new cycle. Okay? This is very easy. But the important thing is that you should look at the direction of the arrows. So we have only one-way data flow. Okay? So the data is going in the same direction all the time. This is different, for example, from the model view MVC pattern, because the MVC pattern, we have the model, the controller, the view, but the only condition is that the model and the view cannot interact with each other, but the model and the controller and the view are interacting in two ways. So it's more difficult to reason about this when the application gets raw and gets large, and gets complicated. Now we are going to talk about Fable. I have to talk about Fable because I created Fable, so I have to put it in any tag. Sorry. But we are going to talk about Fable, this F# to JavaScript compiler. Actually, if you're interested, you can go to we have the site, and you have the REPL here. And if you're interested, this is a very quick way to just check. You can create applications. Oops. Okay. So, for example, a clock application, you have a kind of a UI here with IntelliSense and code error checking, and also with tooltips. So, if you're interested, you can just go here, and you have a lot of Elm examples if you want to check about the architecture. So, for example, famous. So the famous. Okay, so we can have also a to-do app very easily. So going back to the talk. There is a reason to introduce Fable here. It's because there is also an implementation of the Elm architecture for Fable, which is called Fable Elmish. And this implementation uses React as the render engine, so that's the reason I'm connecting React and Elm here, even if in the Elm language they have their own renderer. But I'm going to use Fable for examples. If you don't know F#, don't worry, think about it as pseudocode, because the important thing now is that you get the idea, okay? And as we said, in C#, usually you have this Redux is more popular. There are a few differences. In Redux, you have like a single store, and the way to create the components, it's a bit different. But if you understand the ideas here, it's actually very important to create functional UIs and also to apply it to other fields, like we said, event sourcing, for example. This Fable Elmish has inspired other projects like Fabulous. It's still F#, but if you are interested in the mobile development and you like Xamarin Forms, and you don't have to use to create web apps, you can also use Fabulous, which is Elmish for Xamarin. And as we said, in C# it's usually Redux. I've seen a couple of implementation of Redux, but we are going to focus on the Elm architecture in this talk. So let's go to some, maybe we can see. So how's the time? Okay, I think maybe we can see some code. you can, if you want to see in the computer and you don't want to, actually now F# is coming with the .NET SDK, so it's quite simple. But if you want to have a very, very quick test, you can go here and just, you can see, okay, an application that is having these components we've been talking about. The model, the message, the update function, and the view function. Okay? Let's talk deeper about the messages. So the messages link the view function and the update function. For that, the view function has to receive not only the state, but also a dispatch function. The dispatch function is what will we use to send messages to the runtime, okay? The Elm runtime. And the events, this time, the events doesn't hold much logic. The events, the main mission of the events is just to dispatch these messages, okay? So when events triggered, like on click, on change, etc., this is going just to send a message, and most of the logic is going to go to the update function. So this is, well, for me it's a good thing because it makes your application much easier to maintain. That is that most logic is removed from the events and is moved to the update function. And then also something that I like very much because of my linguistics background is that the messages improve the semantics of raw events. Because when we have on click, on change, on check, etc., this doesn't tell us anything about our application, about our business model, okay? But if we have something like increment, update username, send confirmation to the server, etc., these messages, when we saw them in the code, we have a better idea of what is happening. So this is very important. For example, if you have heard about DDD or domain-driven development, so it's very important to create a language, okay, with your code, that you can read the code and also know what is happening. And also something very important, it's not, when you're creating web applications, you don't have to worry too much because in JavaScript there is only one single thread. But when I was writing Windows Forms applications or Wpf, you had to worry a lot of times about the UI thread, right? So there were race conditions. You didn't know exactly when when you were going to touch the UI. You didn't know if you were in a different thread, if you could have race issues with other events, for example. But in this case, the libraries that are implementing Elmish or Elm architecture, they all must have a queue that deals with the messages in a sequential form. So this means that you dispatch a message, you deal with the message, then you deal with the next one, etc., etc. So there will be no race conditions. This is important. This is also related to the actor model. If you heard about that, something that coming from Erlang, that is a way to deal with concurrent programming, because concurrency is very difficult, and even in UI, most of the times we don't think about it because we only have one user and the events are not very fast. But if you have to deal, for example, with something coming from the servers through live updates, through a WebSocket, for example, things like this, things start to get complicated, and it's good to have this queue that is going to deal with the race conditions. So it's very similar to what we just saw. So this is usually the simplest application that is being shown to explain a web app for Elm, but also for Blazor, they usually have the counter. So in this case, we have the message, that we have increment and decrement. And we have the update function. We are going to check the message and the model. So if we have increment, we are going to update the model with adding 1 to the value. If it's decrement, we just subtract 1. So easy peasy. The view function is just creating a div tag with 2 buttons and a text that is expressing the current value of the model. And as you can see, in the buttons, we have the click events, but the click events, they're just dispatching messages. So in this case, it's much easier to see what's happening because we see button on click, dispatch increment. Okay, so this button is about incrementing the value in our application. The other one is about documenting. So it's even if, in this case, we have plus and minus symbols, so it will be fine. But if we have, for example, an app that is being localized and we only have an ID there and we don't know exactly what this button is about, just looking at the message, we know much better what's the function of this element. When sometimes this update function is, has to be synchronous. We've said that the messages are dealt with sequentially, so the update function has to be synchronous and it has to be fast because we cannot lock the UI. Okay, so you'll say, okay, but there are many operations in the UI apps that are not fast, especially in the web when we have to communicate with the server, like REST calls. In this case, we call about asynchronous functions than in asynchronous actions. Than in Elm, they are called commands, and they are just the way to run an action asynchronously. And the commands are just callbacks that receive the dispatch function as argument. So whenever your asynchronous action has finished, you can just dispatch a new message. So at the end, it's the same thing. It's just you execute an action, and then when it's finished, you dispatch a message, and then this triggers a new update render cycle. So let's imagine, for example, that we have an application where we have to get, where we have to call an API, in this case, this public API, random user, to generate random users. So we just call the API. Again, this is not important, but this promised computation expression, this the way that F# does asynchronous programming. And you just call the API, you get the response, you get the text from the response, you decode it because it's a JSON, and then you return the value. And in the update function, you'll see here in F#, you have type inference, so it's not mandatory all the time, but when you have to write the return type, it goes to the end. So in this case, in the first line, you see at the end that this time we are not returning only a model, but also a command. In this case, the command is just a callback. And you can see here that we have three cases for the message. So we have fetch random user, we have fetch response, and we have fetch error. So when the application said that we should get a new user, we are going to call this, if you see at the end of the first case, we call the get random user function, and then either, if it succeeds, we send the message fetch response, or we send the message fetch error. So if you go to the REPL, for example, there's actually coming from this application, which is called random user. This is a very simple application to, whoops. Oh, it's not working now. Okay, had to happen. Not working now, but this application should generate new users, and here you see that we are returning, in the tooltip, we are returning this command, and this is going to generate new messages. Okay. So there are other notions and concepts in the Elmish architecture, but we are going to just learn about what we call the components. One important thing is that when we talk about components in the Elm architecture, it's just a pattern, okay? So, for example, in React, you'll learn also about components, but this is something different. This is actual entities in the virtual DOM. In the Elm architecture, a pattern is just, a component is just a unit containing a model, a view, and update. So it's just a way to organize your code. But this doesn't mean that you cannot mix both of the concepts. So for example, you can get a React component that is also a component in Elmish, but I just want to tell you that I'm talking a bit something different here. So the usual file structure, if you have a big component, is that you have the types in one file. So you have the message and the model. You have the state, That's usually the update function, and most of the time it's also a init function to initialize your model. And you have the view function also in another file. And the components also organize themselves hierarchically through composition. So this is the same as we saw before with object-oriented programming model, because usually you have this, the buttons and things that were organized using inheritance in object-oriented programming model. But in this case, we do the same, just using function composition. The messages bubble up, so every time that a child is firing a message, they will bubble up to the root of our app, and then the updates and the view will flow top-down, okay? And the children also, if necessary, it's not very common, but also can communicate with the parent by external messages. And everything is a component. So the app, when we talk about the Neolmis app, is just the root component. But it's also a component. If you see this slide, usually if you know a bit about F# or other functional programming languages, the two arrows there, arrowheads, are usually used to mean composition. So in this case, F1, the first function, and the second function, this equivalent to what you see on the bottom, that we just create a new function that applies an argument to the first function and then applies it to the second function. So if you see here, now we are going to add a new component to this control application we had. In this case, we are going to add a text box to decide the delta we want to add when we are incrementing or decrementing the value. So instead of just using one, we let the user decide what they want to use. So in this case, what we have to do is compose everything. So first we compose the message by adding a new case that is just containing messages from the component. Also in the update function, we have to deal with these messages just by calling the update function of the component. And in the view function, if you see at the bottom, last line is also calling the view function of the component. And you see that the dispatch function, we are sending the dispatch function, but we are composing that with the constructor for the delta message. Okay, this, if you are not used to F#, maybe it can be a bit difficult to understand at the beginning, but let's see an example. Can you see the code well, like this? Okay. So we have the counter here, very easy. We already said that, so that we have the model, we have value, we have a function to init the model, we have the message, we have the view, and we are just sending. If we were to change the messages, for example, now it doesn't matter if I click one button or the other, it's always decrementing, okay? But we want to add an extra box so the user can decide how much they want to add. Or so, for example, here now I'm adding 5 instead of 1. And how can we do that? So we have, in this case, because the component is very, very small, we can just have in the same file. So we have the same here, what we've seen. But this will be our component, and the structure is exactly the same. So we have a model, which in this case is just an integer. We have an init function. We have a message that is very easy here. It's just to change. And when we update, we have to check that we can parse the value that is coming from the text box. We can convert it to an integer. Because Fable is translating F#, we can use not everything, but we can use some APIs from .NET. So in this case, we are using system.in32 to parse integers. And now in the view function, we just have the change event, we get the value, and we send the dispatch message, the change message, sorry. So it's really simple. It's just something that is, we are just composing components. And when we send the dispatch, when we call the view function here, we have to send the dispatch function, which is the same. It's just sending a message. Unit is basically the same as void in C#, okay? So it means that the function is not returning a value. It's just executing something. And in this case here, we could just do the following, okay? Dispatch. It's just the same. But we say that the Elm architecture is very simple and we don't have to learn new things for everything because we are just using our programming language to write the UI. So if we want to do something, a special thing, we just can use the functions we already know about. And in this case, if we write something that obviously this is not a number, it cannot be parsed, but now the application is still using the old value. Let's say that, as before, we want to disable the buttons if the user is not entering something correctly here. So how can we do that? So ideally, I will write this on live, but I'm very bad at functional programming because I cannot code and talk at the same time. My colleagues also say that I cannot code and think at the same time, but in this case, we are going just to go to the step 3, and if we want to have some extra logic, we can have, because it's just our programming language. So if we want to say, if we want to enable the button, so we are going to check if the delta is something that now this time we are using an option. An option is how in F# we call something, think of nullable in C#, okay? But if we say that there is an actual value here, we are going to enable this. And if there is no value, you see, the buttons are disabled. But if we put a value, then the buttons are enabled again. Another interesting thing is that because we are just using our programming language, if the button starts to become a bit complicated, because now we have to set up the disable property, the event, the text, etc. We can just refactor it again. We can just create a different function for that, and then we just call the function. Okay, so it's really simple. We don't need to learn about new things because everything is already there. So we already saw that in action. So advantages of this approach. The first advantage, as I just said, is that it removes a lot of cognitive overhead. So we have this, we were thinking about in SAML, in Wpf, we had to think about one-way data bindings, two-way, triggers, command bindings, etc. All of these, they are gone in Elm because we are just using the things that we do when we are programming anything. So composition, calling function, etc., etc. We have just a single language for logic and the view. So this also, again, we are removing cognitive overhead. We have immutability and the message queue that also makes it much easier to reason about the model because we don't have to think about the race conditions. We don't have to think about what is modifying our model. We have snapshots every time. And this also is good to, there are other frameworks that already have it, the hot reloading. But you've shown, while I was coding, that I was making changes and the application wasn't reloading because the new code was being inserted in the application. And because the model is immutable, we can just keep the copy of the model and rerun the application again. Also, time travel is, I don't know if we have time, but I can show you. Time travel is very easy because we can just store the snapshots of the model, and then if we want to go back, we just take the model that we have before, the snapshot, and then rerun the view function again. And it's also very easy to maintain thanks to the repetitive structure. So everything is just repetition. You have seen that the models, they have exactly the same structure. So we just create the new structure, every time again. If we have an application, then somebody who knows the Elm architecture has to come, but doesn't know the application and has to fix a bug or something, at least it's very easy for the new person to just go there to the component, and they will see that everything is exactly the same. So it's really easy to get into an application, an anonymous application. This happened to me. I had to keep working on an application that I didn't create at the beginning, and it was very easy for me because everything was exactly the same as in other applications. But also there are problems, or not problems, or things that it's more difficult to get used to. For example, we have talked about this idea of simplicity, but for some people, actually also for me, for myself included, sometimes it doesn't feel smart enough. This is because we are so used to frameworks that are doing this Wpf, they are doing magic. You have to learn tricks for everything, and then when you have something so simple, it's like, no, this is not right. It's something that is difficult to overcome in our heads, because we tend to feel that if something's too simple, it cannot work well. It's also, I say almost impossible because I haven't seen it. I don't know if somebody could create that, but it's very difficult to have a software designer like for Windows Form or like Wpf, because every time that the model changes, you have to rerun the view function. So usually the hot reloading becomes the software designer, right? Because you are just modifying the code, and then you can see the changes on the screen immediately. So instead of using a designer, you just run the code and see the changes on a screen. It's also more difficult because of this reason for the designer, the person, and the programmer to work separately, okay? In a project, for example, of mine, we have a different designer, and then the designer is using plain HTML, and then we have to take the HTML, we have to translate it. It's not difficult, and there are tools for that, but still you have to translate it, and if there is a change, the designer has to make it in their static HTML, and we have to translate it. It's possible, but there is this step of translation that you have to do. And there is also some boilerplate. Some people complain because, as you have seen, whenever we use a new component, we have to wire the message, we have to wire the update function, we have to wire the view function. And for some people, if you are used to something like a Wpf that does things magically, it doesn't feel right. But it's very good because the compiler is helping you all the time. And in functional programming, that especially in statically typed functional programming, that people are usually obsessed with the correctness of the types. This is also something very good to have. And also related to both React and Elm is that it needs some care to avoid unnecessary renders, because every time that we make any little change, we are like re-rendering the whole UI. So sometimes, especially if we have very frequent changes, we have to, we need some care to make sure that we are not rendering everything all the time. This is usually not a problem, because we say that the React and the virtual DOM, they are going to check that they only need to touch in the DOM, in the actual web page, the things that have changed. But still, if you can memorize some components, it's very easy. It's just when you are creating a component, you say, okay, this component should be lazy or memoized. So it means that if the model for this component hasn't changed, you don't need to run the render function again. So if you do that, it's usually enough. But still something, it's a small thing that you need to care about our performance. So I'll show you very quickly, because I've been showing the let's see. It seems very easy to use just it seems too easy to just see a counter. So let's see something a bit more complicated and how time traveling could work. And hot reloading. So as I told you, now this application is a bit more complicated. So we have the components, and we have components. We have first the type, we have the model, we have some messages here, we have like a sub message. We have the view function. We also have the state. And something that is common, especially with web apps in the Elmis architecture, is that you also have a REST file with the REST calls that you are doing to the server. But here you can see, for example, we have a very simple voting system. There's a small, actually here is just loading the local storage, but a small database that is being stored, so you can keep the state. But the interesting thing is that, as I told you, you can just go to, I think, car, let's see, credit card, for example. You can just make a change, and this is going to be reflected on screen. This one. Another one. Sorry? Sorry, yes, true, you're right. So this one, yeah, you're right, I was changing. Okay, so for example, I change this one, yeah, and you see, I'm not even the scrolling is changing, so this is just, instead of having a designer, we can just make the changes here. And this is using Fulma, which is a very interesting project for Fable that is also abstracting many things that and creating some a bit more complicated and more stylized components that we can. So, for example, buttons here, and you can see the code how to use that. But we can also have time travel debugging here. So, if I go, okay, let's. So if I go back, I just, okay, can you see here how on the left, how I'm reverting my actions? Okay. So yeah, if you're interested in functional programming for UIs, you can check Fable, the Fable website. You can also take one of the screens, one of the stickers. Sorry, not my screen, please. And I just wanted to say спасибо for everything. You have some links here, so you can take the guide for the Elm architecture. You can take Elmis GitHub, which is the implementation for Elmis. Fable compiler is the Twitter for Fable. Also my Twitter, Alfonso GC Núñez. And also we have a very, very small conference for Fable. And you can also check it in the website, fable.io, FableConf. So it will be happening in September. So if you want to go to Belgium and if you're interested in this kind of things, you will be more than welcome. So thanks again.